So today we are going to take one example of the state space representation of the nth order system for the LTI system, that is the linear differential equation, in which the forcing function involves the derivative term, right? So the derivation of this problem has already been done. Today we are going to solve one numerical. So the topic is a state space representation, a representation of nth order systems, right, of linear differential equation, linear differential equation in which the forcing function involves the derivative term, right? So derivative term means, let's say this is the term, this is the one of the linear differential equation where the y to the power n, that is the nth derivative, a1 y n minus 1 n minus 1th derivative, plus dot 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 up to the an minus 1 y dot plus an y, right, is equals to b naught to the power n, means the nth derivative of the u is here, plus b1 u n minus 1, that is the n minus 1th derivative of the input, the forcing function, up to the bn minus 1 u dot plus bnu. So if such type of problem will come in the picture, then how you will solve the problem? We have already derived the 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 derivation for such type of problem, right? So today I'm taking just one example. You can see the previous video, previous derivation for the reference, right? So problem is here, let's say we have ys upon us, let's say 160 upon into s plus 4 divided by s cube plus 18s square plus 192s plus, let's say, 64g, right? So it also may be represented like that in the term of the block diagram. This is, let's say, u, and the controller here for s plus 4 and s plus 16. It is in the, this is in the filter form, right? Filter form, and the transfer function of the process is defined like 40 upon s into s plus 2, right? The second order system is there, right? And then we have the feedback, okay, and the output is taken as a y. So when you solve this transfer function ys upon us, we will got like this one, right? 160 upon into s plus 4 divided by this, okay. So overall this becomes the third order transfer function, right? So solution, if you talking about the solution of the problem, so how we will proceed? So this is the SQ, S square, S 640. So it is obviously it is the third derivative. Yes or no? It is the third derivative. When it is multiplied with the SQ into YS, it means Y having the third derivative. Am I right? Plus you can write. Anyone can tell me what is the next term? Please. Yes, 18.
Sir, 18y double dot
Yes, 18y double dot plus
plus 192
192 y dot plus 640 y equal to, please, 160
160 u dot
u dot plus 4 u.
640.
Yes, 640. Yes, very good. 640 u. So this is the equation for the differential equation for the system, right? Whatever the given in the system. So what we have to do? We have to first define. Let us define. We already told you the fundamental how this is going to solve when the derivative term will be there. The derivative term will be should be 0. So we have defined x1 is equals to y minus beta naught u, right? And x2 is equals to y dot, right, minus of beta naught u dot minus of beta 1 u. If you remember the what we have explained in the previous video, right? And what is this? This is the x1, right? x1 dot, this is the x1 dot, right? x1 dot minus of beta 1 u, right? And what is the x3? x3 is nothing but the x2 dot minus of beta 2 u, right? So you can write y double dot minus of beta naught u double dot minus of beta 1 u dot minus of beta 2 u, that is the x2 dot minus of beta 2 u. This is the fundamental used in the derivation, right? Right? Where कोई प्रॉब्लम किसी को, where we have defined, right, where beta naught, beta 1 and beta 2 are determined from this equation, right? This equation, let's say this equation number 1, this equation number 2. So कैसे हम इसको करेंगे बेटा? हम इसको करेंगे क्या कि बीटा नॉट को डिफाइन करेंगे बी नॉट और दैट इज शुड बी द इक्वल टू 0. यस और नो? सिमिलरली बीटा 1 इज इक्वल्स टू b1 माइनस a1. ये मैंने ऑलरेडी डिफाइन कर रखा है, ये है ना, ये फंक्शन जो है, ये फंक्शन हमने ऑलरेडी, अगर आप ध्यान देंगे प्रीवियस एग्जांपल में, तो हमने इसका डेरिवेटिव, इसका हमने फाइनल इक्वेशन हमने सॉल्व कर रखा था, है ना? ठीक है, जिसमें हमने कहा था, अगर आपको याद हो, बी नॉट माइनस बीटा नॉट इक्वल टू 0, राइट? b1 माइनस बीटा 1 माइनस a1 बीटा नॉट इक्वल टू 0, right? b2 minus beta 2 minus a1 beta 1 minus a2 beta naught equal to 0. We already solved such type of equation, right? So then based on that, when you solve b1 minus a1 beta naught equal to 0, right? Beta 2 is equals to beta 2 minus a1 beta 1 minus a2 beta naught equal to 0, and obviously beta 3, and beta 3 becomes b3 minus a1 beta 2 minus a2 beta 1 minus a3 beta not equal to 0, right? और ये जो इक्वेशन आएगा जब सॉल्व करोगे इसको, when you solve this equation it will becomes minus 2240, right? So ultimately your equation becomes x1 dot, just to practice है ना, आप प्रैक्टिस कीजिए, अपने आप आ जाएगा. जब आपने डेरिवेशन कराया है उस डेरिवेशन को आप सॉल्व करें दोबारा से, देन यू विल एबल टू सॉल्व, अदरवाइज यू विल फेस प्रॉब्लम. सो 0 1 0 0 0 1 minus 640 minus 192 minus 18 x1 x2 x3 x1 x2 x3, and then b1 b naught, तो 0 160 minus 2240 क्या हो जाएगा यहाँ पर आपका u, and y obviously this is the x1, so 1 0 0 x1 x2 x2. So this is the solution for the problem. Just try to solve है ना, इसको आप खुद से ट्राई कीजिए सॉल्व करना, otherwise you will be the problem, right? So now I am going to start with the new topic, that is the homogeneous state equation. What do you understand by the homogeneous and non-homogeneous equation? First of all, tell me. So the problem is solution of, very important, solution of time invariant. Then we will discuss the time variant. First we are going to discuss the time invariant, solution of time invariant state equation, right? और इसमें भी आपके दो तरह के टाइम इनवेरिएंट स्टेट इक्वेशन होगा. फर्स्ट वन इज द फॉर अ टाइम इनवेरिएंट सिस्टम, the state equation is given by, the state equation कैसा होगा? The state equation is defined as x dot t is equals to, please tell me, axt plus, please, but, yes or no? Okay. And this equation, this equation which may be divided into two types, into two category, you can say, or two types. First one is, the homogeneous equation. So please tell me, what is the homogeneous equation? Anyone? Homogeneous state equation? Anyone? So if A is constant matrix and U is, please, क्या होगा U? U is, please, U is, what is homogeneous? मैंने बता रखा है यार. Homogeneous means U is 0.
0.
U is 0 vector, right? In this case, you can say simple. In this case, no control force. Okay, no control force are applied. ये हमने पहले ही देख रखा है homogeneous का example. However, in the case of the non-homogeneous, आपने देखा है x dot t is equals to axt. Yes or no? We already solve. और xt where u है ही नहीं हमका, u is a 0. U is 0. And in the second case, u is present. And in third case, u is differentiated into two forms. First, either it contains only the constant term, and second is the terms on where the derivative terms will come, right? So these are the category. So second one is the non-homogeneous equation, homogeneous state equation. And in this, if a is constant, right? A is constant matrix, and u is, u is non-zero vector, right? Non-zero vector. What is the example? Example, if you say discharging of capacitor, discharging of capacitor, इसको किस कौन सी कैटेगरी में रखेंगे? Homogeneous, right? Because there is no control force, no control force is there in order to discharge the capacitor. However, in the total, when you find out the total response of the RLC circuit, you can say, अगर केवल कैपेसिटर की बात करें, then it will come in the homogeneous. However, if you taking the total response, okay, because where the V naught, V in is applied, right? The voltage is applied, है ना? That becomes example of, please tell me, example of the non-homogeneous, right? Homogeneous, right? So first method, that is very simple method I am taking, and that is by using the Laplace transform, solution of homogeneous equation, solution of homogeneous state equation using Laplace transform, right? Then we will only take the differential equation, and how the differential equation will solve, we will see after this. The solution of homogeneous, let's say we have the equation x dot t is equals to axt plus but, and since it is a homogeneous, so you can simply write for unforced, it is the unforced response, right? Unforced response, it means ut equal to 0. Am I right? Any problem? Students?
No, sir.
Okay, so ut is 0 in this case, the homogeneous, right? So then you can write simply the x dot t is equals to axt. Naj, is it clear?
Yes,
Naj,
sir.
okay. Any problem? If you don't know the derivation, then you can't able to solve the numerical problem. Simple. Okay, so focus on the derivation, right? So for the unforced response, the concept is we are considering ut equal to 0. then the equation becomes x dot t is equals to axt, right? Now let us consider the analogous, right? एनालॉगस स्केलर फंक्शन इसको हम क्या कर रहे हैं अभी हम a और b क्या है a and b the vector, right? A and b the matrix, right? And it is the matrix. So simple अभी हम क्या कर रहे हैं इसको इजीली सॉल्व करने के लिए जस्ट वी आर कंसीडरिंग दैट it is nothing but the scalar function. It is nothing. A is the scalar function, right? A scalar function. It is not a vector or not a matrix. Simple, it is the scalar, right? So what is the this is the d by dt of xt, or it is axt, right? So take the Laplace transform. What is the Laplace transform of this function? Please taking
Yes,
Laplace
sir.
Laplace transform. What will become? Please tell me.
Sir, S
What is the
axis.
Yes.
yes s into xs
Axis
minus
is equals
of
to A.
x0 is equals to a xs, right?
Yes,
Am
sir.
I clear?
Yes,
Okay,
sir.
so it is, you can write that s minus a into xs is equals to x0. It is clear? You can write. So you can write also x of s is equals to s minus a inverse x0. ठीक है? ठीक है? Yes or no? And it can be
Yes, sir.
written as xs is equals to 1 upon s minus a x0. And what is the Laplace inverse transform? What is xt now? xt क्या बनेगा? What is the 1 upon s minus a? Sorry.
Power minus 80.
E to the power 80. Yes. E to minus 80 or e to the power 80?
80.
E to the power plus 80, right? E to the power 80 x0.
80.
X0, right? So you can say that for the scalar function, it is the xt is equals to e to the power 80. So for if it is generalized, for the vector function axt, then it become ये क्या बन जाएगा बेटा? Then it become xt is equals to, please tell me, xt is equals to e to the power 80 x naught. Any problem?
No, sir.
Okay. Okay. So now we are going to define a new function, that is the e to the power 80. पता है किसको क्या कहते हैं e to the power 80 को? Anyone?
Sir, STM, state
Very good. E to the
transmission.
power 80 is defined as the phi t, and phi t is the nothing but the STM, state transition matrix. State transition
Transition
matrix.
matrix.
State transition matrix. State transition matrix. Okay. Therefore, you can say that the xt is equals to nothing but the phi t into x0. Phi t into x of 0. ठीक है? Okay. So now you can also say if phi t is known, अगर आपको phi t पता है, if phi t is known, then it is possible to transit from x naught to xt. अगर आप, if you know x naught, you will know. If you know this value phi t, then it means you are going to find out the xt value. It means x naught to xt you can find out, right? So therefore phi t is known as, it is transition from x naught to xt. You will reach from x naught to xt, and therefore it is known as a state transition. A state transition matrix, right? A state transition. It is a transition from x naught to xt if you know the phi t, and therefore it is called the state transition matrix, STM, right? STM. And if you see the equation, that is the phi t, and phi t is nothing but, you know, the e to the power 80, and e to the power 80 has the expansion, right? कैसा होगा expansion? I plus 80 plus a square t square, sorry, factorial 2 plus aq tq factorial 3, and so on. And if you to generalize, then you can write summation of I equal to 0 to n ai t, sorry, क्या होगा जी, ए आई दैट इज द आई सब सुपरस्क्रिप्ट में आई टी आई टू द पावर यानी फैक्टोरियल आई. एम आई राइट? एनी प्रॉब्लम?
No, sir.
Okay.
No, sir.
So you can write phi t is equals to Laplace inverse. This is a Laplace inverse symbol, right? Laplace inverse of the phi s. And what is the phi s? Phi s nothing but you know si minus a, है ना, inverse, si minus a inverse, right? Right? Or the important thing, the important point should be remember where the phi s. What is phi s? Phi s is equals to si minus a inverse, right? This is known as, this is known as, anyone can tell me what is the equation known as si minus a inverse? Resolvent. Resolvent matrix. Remember, this is the resolvent matrix. Phi s is the resolvent matrix, right? Okay. See, one characteristic of this equation, let's say this is the phi t. Okay, अगर हम इस phi का inverse ले ले, let's take the inverse of this phi function, then what will come? Phi t is equals to what? Phi t is equals to given as a e to the power at. Then phi inverse become e to the power minus at. Am I right? Yes or no?
Yes, sir.
Or
Yes, sir.
what is the what is the phi of minus t? If phi t is equals to e to the power at, then what is the phi of minus t?
3 to the
5.
power minus
E to the
Yes,
power
80.
minus 80.
80.
So it may be written as a phi of minus t. Yes or no? It means phi inverse t is equals to e to the power minus 80. That is the phi of minus t. Right? अच्छा, अब इसके आगे चलते हैं थोड़ा. Now, if the eigenvalue, let's say lambda 1, lambda 2 up to the lambda n of the matrix A, you know, the matrix A will provide the eigenvalue. How? कैसे provide करते हैं बेटा?
So solution of characteristic equation.
Solution of, yes, solution of that characteristic equation will provide the eigenvalue, right? So eigen R, let's say it is distinct. कुछ देर के लिए मान लेते हैं distinct है. If it is not, it is not always possible to, it is a distinct. Okay. So let's say if the eigenvalue lambda 1 to the lambda n of the matrix A are distinct, right? Then your phi t, okay, then your phi t will contain the n exponent, that is, n exponent means, what is the meaning of exponent? E to the power lambda 1t, e to the power lambda 2t, e to the power lambda 3t, and so on, e to the power lambda nt. तो इन पार्टिकुलर ये कैसा बन गया इक्वेशन? इन पार्टिकुलर इफ द मैट्रिक्स ए इज, उसको हम लोग डायगोनल मैट्रिक्स अगर है, और आपको पता है कि डायगोनल मैट्रिक्स होता है, तो उसका जो डायगोनल है दैट विल गिव द क्या दैट इज द, that will provide the eigenvalue. Yes or no? That phi t becomes e to the power 80, and that is your e to the power lambda 1t, e to the power lambda 2t, so on, e to the power lambda n t, e to the power lambda n t, right? Where A is the diagonal matrix. A is the diagonal matrix, right? ठीक है? एनी प्रॉब्लम? अच्छा, अगर ये आपका डिस्टिंक्ट नहीं है तब क्या होगा? इफ दिस इज रिपीटेटिव, मे बी बाई डिस्टिंक्ट इसका मतलब क्या है? इसका मतलब ये हुआ कि सम वैल्यू आर रिपीटेटिव. एम आई राइट? अरे हाँ या ना तो बोलो यार. if the
Yes,
lambda
sir.
1, lambda 2, lambda n is not distinct, what it means? It means some of the eigenvalue are the multiple eigenvalue are there. Yes or no? So what happened in that case? Let's say if there is a multiplicity in the eigenvalue, in the eigenvalues, let's say एग्जांपल अगर हम ले लें कि भाई लैम्डा 1 है, लैम्डा 1 है, लैम्डा 1 है, then lambda 4, lambda 5, lambda 1 to lambda 3 are the same, lambda 1, lambda 1, lambda 1, lambda 5 and up to the lambda n. So yeah, there are three roots, or you can say there are three eigenvalue are in the repetition. Okay, then your phi t will become कैसा बनेगा? Then your phi t will contain in addition. Anyone can tell me what will be the equation to be written to the exponential सेम ऐसे ही होगा, बस अंतर क्या होगा? e to the power lambda 1 t फर्स्ट वन, राइट. सेकेंड वन क्या हो जाएगा? Anyone can tell me? t to the power lambda, sorry, t into the power lambda t square e to the power lambda 1 t, right? And फिर से सेम, that is the e to the power lambda 4t, e to the power lambda 5t and e to the power lambda nt, right? कोई प्रॉब्लम समझ में आया कि नहीं आया? If it is a repetitive, then you have to t स्क्वायर t क्यूब, जितना आपका टर्म रिपीट होगा उतना आप वहां पर उतना तक लिखेंगे, बाकी सब सेम रहेगा. दिस इज बिकम्स लैम्डा t इंटू लैम्डा 1t, t स्क्वायर लैम्डा 1t. ठीक है, इट इज क्लियर?
Yes, sir.
Okay. Now the second way to see the same problem in order to solve a state homogeneous state equation, let's see the second method to solve the homogeneous state. You can say second method to see this same equation, homogeneous state equation, solution of the homogeneous state equation. Let's say we have the equation. Since you know this is a homogeneous state equation, so you can write simply x dot is equals to ax, right? Where xt is equals to, let's say this is the xt, right? X dot t is equals to axt, and where let's say consider xt is equals to b naught plus b1t plus b2t square, like bkt to the power k. Let's say this is the polynomial. Now substitute this equation by substituting. X dot become a b naught plus b1t plus b2t square up to the bk t to the power k plus dot dot dot. Is it clear? You can write here a b naught plus a b1 t plus a b2 t square up to the a bk t power k up to this point. Yes or no? Okay. Now since this is a xt, then what can you tell me what is the dy dt of xt? Dy dt of xt. What is the dy dt of xt? What is the x naught t? Since this is the xt, then can you tell me what is the x dot t? Please. What is the x naught t? Bolo?
B1 plus 2 B2.
b1 plus 2 b2t, yes, right, plus dot 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 up to the k bk, right, t to the power k minus 1 plus dot dot dot. यही तो होगा अगर आप इसको सॉल्व करें तो. First term will be the 0, right? So compare this is the same equation, x dot t, this is also the x dot t, this is also x dot t. The comparing equation number 1 and 2, what will become? What you got? You can say that the b1 is nothing but the a b naught. b2 is nothing but the a b1. b2 is nothing but the a b1. And what is b1? b1 is a b naught. You can say b2 is equals to a b1, and it is the a b naught. This is the a square b naught. A square b naught, right? Am I right? Any problem? कि गलत है?
Sir, 2b2 is equal
Yes,
to a square.
2b2. Very good. 2b2. 2b2. Right. So b2 becomes, very good. b2 becomes 1 by 2 a square b naught. You are right. Thank you. In similar way, you can write for the b3. b3 becomes 1 by 3 a b2, and b2 is like this one. b2 is like this, right? So it becomes, you can say that 1 by factorial 3, क्योंकि ये 2 है तो 6 हो जाएगा, 1 by 6. It becomes 1 by 6 a cube b naught, right? So it can be written as a 1 by factorial 3 a cube b naught, right? So if you generalize to up to the bk, then what is the bk? Can tell me what is the bk? 1 by factorial k a to the power k b naught, right? Yes or no?
Yes, sir.
So sorry, if you know the value of b naught, and what is the b naught? What is the b naught? b naught है क्या? b naught is this value. b naught is this constant value, and this constant value can be evaluated when you put t equal to 0. If you put the t equal to 0, then only the b naught will come. Yes or no?
Yes, sir.
So it means this is the initial value. So you can write here, if you know the value of b naught is, you can say determine. You can determine by substituting the value t equal to 0. So x naught become nothing but the b naught. So if x naught is the b naught, then what is now xt? Just put value of the value. Xt equals to becomes 1 plus at plus 1 by factorial 2 a square t square up to the 1 upon factorial k a power k b power k, sorry, a to the power t to the power k and so on, and साथ में आपका x naught, क्योंकि this is the b naught, and b naught can you be evaluated as x naught, right? So it is what? ये क्या है? ये है क्या? What is this? What is this? This is expansion of what?
e raised to 80.
E to the power 80. Yes, very good. E to the power 80 x naught. So ultimately, again we have find out the same equation. Xt is equals to e to the power 80 x naught, right? E to the power 80 x naught. ठीक है? So for the it is the scale, for the a is the scalar function. No, a is the scalar function. If you put the vector function, that is the x dot t is equals to a xt, then your equation becomes, the solution becomes xt is equals to, you can say, e to the power 80 x naught t. This is the solution. This is the solution, right? Where you can say simple, e to the power 80 is nothing but the summation of k equal to 0 or I equal to 0 to infinite है ना, a to the power k t to the power k factorial k. So इस तरीके से आप इसको कर सकते हैं. और remember, e to the power 80 is converges, है ना, converging है ये, absolute converging function है ये. It is the absolute converging function for all finite value of t. For all finite value of t. Yes or no? If you know the t, then it is the well defined, well converging function. Yes or no? So ये तो बात हो गया आपका. ठीक है. अच्छा, अब एक एग्जांपल, एक प्रॉपर्टी और है. You know, e to the power a plus b into t, if you write, then it means you can write as a e to the power 80 into e to the power bt, right? ठीक है, तो ये इक्वेशन you can always write whenever AB is equals to BA exist. If it is not exist, if AB is equals to not BA, then you can't write e to the power A plus BT is equals to e to the power AT into e to the power BT. Remember, right? So this is the property. So I am now coming on the property of the state transition matrix. State transition matrix, that is very very important and may be asked in the exam. So that is the properties of state transition matrix. State transition matrix. Okay. So just I am stopping